oil was of gas. In fact, there are enormous movements of the crust as the center began to cool. When folding happened, well, it was like the earth fell back onto itself. And when folding happened, it was well one layer was forced by rocks above down through the layers below. So you can see that the repositioning of porous and non-porous rock. This repositioning would have affected the movement of oil. When the earth shifted, cracks would have been opened, and non-porous rock layers would have been dropped over channels that had previously been used as the pathway for the transform oil and gas to the surface. Okay, as geologists, we are interested in locating the troughs. Now, why would that be so? Because that's where we'll find the oil and gas reserves. And that's what I really want to talk about today. So there are several different types of troughs. But today we are going to talk about the three most common ones: the anticline trough, the salt dome trough, and the fault trough. Look at this diagram. Here's an example of an anticline. As you can see, the oil is trapped under a formation of rock that resembles an arch. That's because the arch was bent from a previously flat formation by uplifting. In this anticline, the petroleum is trapped under a formation of non-porous rock with a gas deposit directly over it. This is fairly typical of an anticline because gas isn't as dense as oil. It rises above it. The dome over the top can be rock, as in this example, or it could be a layer of clay. The important thing is that the cap of non-porous material won't let the oil or gas pass upward or sideways around it. The important thing is that the cap of non-porous material won't let the oil and gas pass upward or sideways around it.